Hello students, welcome to lecture 18. So in this session, we will be discussing RC firing circuit. So in the previous class, we discussed resistance triggering circuit. In this class, we will be discussing resistor capacitor, that is RC triggering circuit of an SCR. And by the end of the session, you'll be able to describe the half wave and full wave RC triggering circuit. Okay, so when you see that there is RC component, that is RC network in this triggering circuit, so which means the time constant tau is responsible or will be used to control the firing angle. Okay, so the elements used in this triggering circuit will be resistor and capacitor, obviously. So the value of the resistor and capacitor will be actually defining the firing angle. That is, the time constant RC will control the firing angle of an SCR. All right. So the circuit of half wave RC circuit is shown here. Half wave means obviously in the negative cycle there will be no output across load. Okay, so the simple arrangement of the components are shown here. So here is your input, AC input, the load connected here, and this circuit forms the triggering circuit. Okay, so there is R, there is C, then you have two diodes, diode D1 and D2, which will control the biasing. Okay, and here is your thyristor or the SCR. Okay, so to understand the working of this circuit, first we'll start with the negative cycle. All right, so during the negative cycle, so all these points I've just now mentioned, which I'll be explaining here. So during the negative cycle of the supply, all right, the capacitor will charge in this fashion. The path of current flow will be in this. So the lower plate will be positive and the upper plate of the capacitor will be negative. Okay, so in the negative cycle, the capacitor will charge via diode D2. All right, so it will charge to the maximum voltage of the input voltage. So the voltage across VC will be equal to minus Vn. That will be in negative cycle. All right, so let us observe the waveform here. So this is your input Vs. Okay, starting from the negative cycle. During the negative cycle, negative cycle, you know, the polarity here will be negative and here it will be positive. So capacitor will charge via D2. All right, so if you observe here, at this potential here is negative and potential across this point will be higher compared to this. So the diode D2 will be conducting, so capacitor will be charging via D2. Okay, so the capacitor will charge to the maximum value of the magnitude of the input signal, which will be that is the voltage across capacitor will be equal to minus Vm. All right, so this value will remain there till the input signal crosses 0. Okay, so till the input crosses 0, the voltage across capacitor will be maintained at minus Vm. Okay, now what happens in the positive cycle? During positive cycle of the input, the polarity at this point will be positive and here it is negative. So capacitor will charge via R. Okay, so now upper plate will be with positive and the lower plate of the capacitor will be negative and capacitor will charge via R. So this will be the path. Okay, now observe the waveform. So the capacitor voltage which was at this point during the positive cycle, when the input crosses 0 and it goes positive, the capacitor starts getting charged and the voltage across the capacitor will raise in a positive direction. It will increase in the positive direction. Okay. So there is, as capacitor getting charged, what happens? You can also observe that the potential developed here is forward biasing diode D1. Okay. So when the diode is conducting, the voltage coming at this gate terminal, all right, if it is equal to VGT, that is gate triggering threshold voltage specified by the manufacturer, that is the limit which would require to turn on the device. So if the voltage coming here, okay, via D1, if it is reaching or equal to VGT, all right, then the SCR will trigger or the SCR will turn on. Okay. Now recall, we are discussing the triggering circuit and we are now discussing RC triggering circuit. How R and C will be responsible to turn on the SCR is what we are discussing. All right. So just you can pause and go back and look at the explanation. So now once this voltage, VC voltage, if it is equal to VGT, now observe here this VGT, it should be equal to, it should be the summation of the drop across D1 plus the minimum gate voltage that is required, that will be specified, right? So if VC, if it is equal to VG minimum plus VD1, all right, then at that point the SCR will turn on. Okay, I hope that is clear. All right. So what happens then? Once SCR is now triggered, what happens? Observe here. Here is our circuit. Okay. So just to brief, at the negative cycle, during the negative cycle, the capacitor will charge to minus Vm. Okay. During positive cycle, the voltage now starts raising up. Once the voltage across capacitor it reaches VGT, okay, the SCR will turn on. So when the SCR is turned on, what happens? The circuit here, it completes. So at that point, when the SCR is turned on, you can observe the voltage at the load. Till then, the output at the load will be 0, or there will be no output that could be observed at the load. Zero here means you should understand it will be very minimum. So because we are talking about power electronics and the high voltage range and current ranges, so the zero here means it is negligible. So we will not use here onwards negligible. So we will take it as 0. All right. So once the SCR is turned on, the voltage across the load will be following the input. So say at this point the SCR is triggered. Okay. So from then the output will follow the input. That is the average output voltage that you can measure across the load will be same as the input. Now, if you observe the voltage across the SCR, if you observe, all right, till it was not turned on, it was acting as an open switch. So whatever you had applied, the input voltage, what you applied, so that was visible across SCR. Once it is turned on, after it is turned on, then the voltage across SCR will drop, will become 0. So that you can observe here. So the moment SCR is turned on, the voltage across SCR is 0. So during the negative cycle, as you know, as the voltage reverses, it is negative. SCR is again now turned off. So turned off means again it acts as an open switch. So whatever you are applying, the input is visible or it is appearing at the SCR. All right. So that will again continue till the capacitor now again charges in the negative cycle and charges again during the positive cycle. Then when it reaches VGT, the voltage across capacitor, when it reaches VGT, then again SCR will turn on and you can observe the output voltage across the load. So now this is the condition when R is very high. Okay. Now observe here the moment or the time taken for the SCR to turn on. So it is depending on this alpha, right? So the how much of time is taken for this capacitor to charge to this level, all right? It is given by the time constant alpha tau, and which is nothing but the product of R and C. If the value of R is high, then the time taken for the voltage of the capacitor to reach this point will be more, isn't it? So that's why it is going, the steep is very slow and it is quite longer, okay? So to reach this point. Let's observe what happens if the R value is less. For low value of R, observe capacitor will the product R and C product will be now less compared to the previous condition. So tau will be less, which means that the time taken for the capacitor to charge here in this duration, it will be faster. So it will reach VGT quite faster, so which will be triggering or turning on the SCR faster or quicker, right? So observe the output voltage and the voltage across SCR here. Now if you observe the voltage across, that is what we call it as average output across the load, V naught, average output voltage across load. If you observe here, then you have the duration of this much, okay? So alpha has now reduced, isn't it? Which means that the triggering angle is less now. That means the SCR is getting turned on with a faster or lower value of firing angle, or it is getting fired faster. That's the meaning. Now if you observe the voltage across SCR, so initially this is the voltage which is following or similar to the input. The moment it is turned on, the voltage across SCR will be 0, and during the negative cycle it will the same input will be appearing across SCR. Now if you compare both the conditions, all right, oh okay, I have not put that, okay, this is for R value, higher value. Observe here the alpha is longer, it is taking more time. For the time taken for the capacitor to charge is more when the value of R is high, okay? So therefore the firing angle also will be more here, isn't it? For low value of R, the time taken for the capacitor to charge will be less, so the firing angle also will be less, okay? But if you observe the average output voltage, if you observe the average output voltage of the load, okay, then you can say that the firing angle is inversely proportional to the output voltage, isn't it? So lesser the firing angle, the average output voltage across load will be more, okay? Higher the firing angle, the average output voltage across the load will be less, okay? So by controlling this firing angle, you can control the average output across the load. So based on the application, based on where you are using, okay, you can control the output voltage across load. How? By controlling the firing angle. And how do you control the firing angle? By adjusting this R, okay? For higher values of R, alpha will be more. For lower values of R, alpha will be less, okay? So if you compare this RC triggering circuit, if you compare with that of resistance triggering circuit. In resistance triggering circuit, we were able to control this alpha only between 0 to 90, isn't it? Yeah. Whereas this circuit, here you can control alpha from 0 to 180 degrees. So based on the value of R, you can control alpha from 0 to 180. So exactly not 0 and 180, but 1 or 2 degrees here and there, you can reach up to 0. Okay. So that's the advantage of this RC triggering circuit. So a few more points to recall here. So in the range of power frequencies, this value, that is RC, the product RC or the time constant tau, for zero output voltage can be taken as RC should be greater than 1.3 T by 2, where T is your frequency of your AC line. All right. So where you can also take it as 4 by omega. Omega is nothing but our 2 pi f. So f is nothing but the frequency of the AC line. Okay. Now one more point to remember or understand here. At triggering, that is the moment the SCR triggers, it is where the voltage across capacitor is equal to VGT, where VGT is given by VG minimum plus VD1. Okay, the minimum requirement at the gate terminal, the voltage that is required, plus the voltage across diode D1. So both together, if it is enough, then that will be triggering the SCR. So that is our actually the gate triggering voltage. All right. So based on this, the maximum value of R can be found as, so this would be the voltage, that is Vs. It should be greater than or equal to Ig minimum R plus Vc. All right. So the moment of the input voltage at which the triggering would take place. So this Vs, it should be greater than or equal to Ig minimum R plus Vc. Vc is your voltage across capacitor. So from this relation, if you substitute Vc, where we got it as VGT, VGT is nothing but Vg minimum plus Vd1. Substituting there, then you have the R value, you'll get the R value, that is it should be less than or equal to Vs minus Vg minimum minus Vd1 divided by Ig minimum. Alright, so all these are relations which you have to just recall and understand. So according to this, Vs is the instantaneous supply voltage at which the SCR will turn on. Okay, so this is the relation at which SCR would exactly get turned on. Okay, and based on this information, you get what should be the R value. So according to this condition, you have to design or adjust the variable resistor so that you will trigger the SCR. All right. Okay, fine. So moving on, we'll move on to full wave circuit. So RC full wave circuit, as you can see, you have the full wave, rectifier circuit there. You have the bridge network. So which means that using this bridge network, you will be eliminating the negative half cycle. So all negative half cycles will be converted or rectified to positive, right? So there will be um, positive response or the positive cycle responses during uh, during every half cycle. That's the meaning. Okay, so the working is similar. All right, only difference is that at the input you have the bridge network. That's all. So there is no negative or reverse voltage that will be applied here. So here again you have RC triggering circuit which is connected to the gate terminal of the SCR. Okay, and the working can be again understood with high value of R and low value of R. So based on this input again, the voltage across the output voltage and VT and VD. VD is nothing but here the voltage across these 2 points. All right. So if you observe, the output what you are getting from this full wave bridge network is your VD. All right. You are having a full wave rectified output. Okay. And this dotted line VC is nothing but your voltage across your capacitor. So based on the value of R, okay, capacitor voltage develops. All right, the capacitor gets charged and the voltage across capacitor is developing. All right, if the value of R is high, then the time taken for this voltage across capacitor to raise and reach this VGT level is more. Okay, it is taking more time. Okay, based on the value of R. If the value of R is high, then this time or the voltage to reach to VGT will be more. In turn, it means that the alpha angle will be more. So once this voltage, VC voltage reaches VGT, that is when the SCR will trigger. It will turn on. So when the SCR turns on, you know the voltage across the load will be observed. Okay, the voltage across load will appear after the SCR is turned on. Okay, till then it will be 0. Recall? Yeah. So similarly, the voltage across SCR VT, if you observe, initially it will be following the input, that is VD. VD is the voltage that is appearing to this circuit. All right. So rectified, full wave rectified output. So every cycle you are having positive response there. So VT will be following this VD till it turns on. So once it is turns on, SCR is on, the voltage across SCR will be 0. Okay. So it goes back and it will be following VD. All right. Now this is the condition when R value is quite high. If R value is low, so as we had discussed in the previous discussion for half wave, so the time taken for the capacitor to charge, okay, or the voltage VC to reach VGT will be less when R value is less. When R value is less, it means that the product RC will be less, which means the time constant to charge the capacitor will be less. The charging of the capacitor will be faster. That's the meaning. So when it is faster, it will reach VGT very soon. Okay. So the SCR will turn on at this moment itself. It will reach this VGT sooner. So it will the SCR will turn on at this point, and you can see the output can be visualized, or the output appears at the load. Okay. Similarly, the voltage across SCR can be observed here. Till it is not turned on, it is following the VD voltage. Once it is turned on, the voltage across SCR will be 0. So that is repeating for every half cycle. I hope you are able to understand and visualize. Now compare here with both the conditions for high value of R and low value of R. So the time constant tau, it is depending on the value of R, isn't it? So varying the R value, you are able to vary this time constant. So varying the time constant is nothing but the time taken for the capacitor to charge. Okay. So which means the voltage across the capacitor will be changing, increasing. Okay. So at what moment the voltage across capacitor reaches or it becomes equal to VGT, Okay, that is when the SCR will turn on. All right. For high value of R, it is taking more time, which means alpha will be more. For low value of R, it is taking less time to charge and reach VGT, so alpha will be less. So based on R value, you can control this. Okay, alpha is controlled. So that is about the RC triggering circuit. We have discussed half wave and full wave. So please go through the sessions. If you have doubt, get it clarified. Um, Go through the recording again and again. You can pause and go through the explanation. If you have any doubts, please get back. Okay, thank you. See you in the next session.